Hi, welcome to the Bio-81 Tutoring Center videos. Today we're going to be talking about climate, and as it is going to kind of be important as we talk about ecology and how it influences organisms. So to start off, we need to define climate. Climate is defined as a long-term prevailing weather conditions in an area. So the weather in an area can change from day to day or week to week, but we classify the overall climate of an area as kind of the average of all those weather conditions. And so climate is kind of based on 4 abiotic factors. Those are temperature, precipitation, wind, and sunlight. And so we're going to kind of look at how those can affect climate. And so when we talk about climate, we can talk about 2 different levels, a micro or macro climate. So macro climate deals with the global climate and the regional and local climates of areas. And microclimate deals with the very small details of a particular community and their climate and how it affects them. So we're going to start off by looking at the global climate of our planet, and it is influenced a lot by wind patterns and current water patterns and by the amount of sunlight that is hitting the earth. So the first thing that we have is we have latitudinal variation in the sunlight intensity. So because the earth is curved, certain areas of earth receive different amount of light. So at the equator, at 0 degrees on the latitude, we get pretty direct sunlight hitting the earth, whereas at lower or higher areas we get lower angles, and so it's more of an oblique, so they get less sunlight. And so that's why we have a pretty warm temperature around the equator regions, and we get colder temperatures around the poles. Along with this latitudinal variation in sunlight intensity, we have seasonal variations in sunlight intensity, and that all is because of Earth's axis that is tilted. So as we know, the Earth moves around the sun, and because of its axes at different times or positions, it will have different sides that face at slightly different angles. So you need to know what the March equinox and September equinox are, and the December and June solstices. So during the March equinox, the tilt is kind of evenly distributed, so we have about the same amount of sunlight hitting all regions of the earth. So we'll have 12 hours of daylight and 12 hours of night. And the same kind of thing happens at the September equinox. With the June and December, it's a little bit different. At the June solstice, the northern hemisphere is tilted more towards the sun. And so because of that, we have our longest days and our shortest nights in the northern hemisphere, but in the southern hemisphere, it's the opposite. We have our shortest days and longest nights. And then the December equinox is just the opposite of that. The southern hemisphere is tilted more towards the sun, and so we have our shortest days and longest nights in the northern hemisphere, and in the southern hemisphere we have our longest days and shortest nights. So they kind of flip-flop from each other. And so that kind of explains why we have different seasons, how in June we have different temperatures than we have in December. It has to do with Earth's axis being tilted and how much sunlight we're receiving because of that tilt. Another thing is air circulation and precipitation patterns. So as we mentioned, most of the direct sunlight hits around the equator. So as that sun is hitting that area, it has the ability to evaporate a lot of the water in the region. And so it will evaporate the water, and that water will ascend. And as it ascends, it will drop back down the moisture, because ascending moist air releases moisture. And so then that air will move to other regions where there's less warm air, or other regions, more towards each of the poles. And as it does that, descending dry air will absorb the moisture around it. And so we have this common pattern that we see right around 30 degrees north or south. We find a lot of our deserts because of this pattern of this dry air descending and taking up the moisture, whereas at the equators it's pretty humid and moist, because the ascending moist air drops all the water and we have a lot of precipitation. And the last one is wind patterns. We just have different wind patterns because of the different temperatures of the air the warm air will rise, and then it will cause colder air to rush in, and so we're able to track these different wind patterns. Now we're going to talk about regional, local, and seasonality. So a lot of things will influence the local and regional climate of areas. And one of those is bodies of water. So depending on if you're near to large bodies of water, such as oceans and lakes, we're going to have a different sort of climate. And that's because of water's ability to keep climate's kind of constant, or temperature's kind of constant. And it's due, it all goes back to water's high specific heat. So it takes a lot of energy to cool down or heat up water. And so what will happen is during the day or during the summer, the air over the land will warm up. But the air over the water won't as much because the water takes more energy to heat up. And so this warm air will rise, and as it rises, the cool water from the ocean will come in to take its place. And so what should have been a really hot area is now been kind of decreased in how hot it could have been because this cool air comes and replaces it. And then as this warm air rises, it cools because it's at higher elevations, and the cool air sinks back down. And so then what also can happen is at night, if it's really cold, the warmer air over the water can come in and replace that colder air. And so we're able to kind of moderate these temperatures. And so if you're near bodies of water, such as in Washington or California, right next to the coast, you don't have huge fluctuations, where if you're more inland, you can have huge fluctuations from day to night. And also these areas experience more precipitation just because of how close they are to the water. Another thing that can influence regional climate is mountains. Mountains can be influential in the climate because they influence light. And so depending on what way the mountain is facing in regards to the sun, you can have different climates. Places that are getting hit very directly by the sun will be drier and hotter. And we also have this thing that arises called the rain shadow. And so what happens is we will have we'll have air that is going over a mountain, and as it rises, it's going to drop all of its precipitation on one side of the mountain. And so it drops most of its precipitation, and then as it falls back down on the leeward side of the mountain, or the other side of the mountain, it's no longer moist. And so it's going to be that kind of descending dry air that's going to be picking up moisture. So we find all over the world places that are on the other side of huge mountain ranges, they can tend to be pretty dry or desert-like. And then the last thing is seasonality. So different places, depending on where they are, will have variations from season to season. For example, here in Rexburg, Idaho, in the summer we get pretty hot, not too bad, but 80s, 90s. In the winter we can get really cold with our snow, and so we have these different seasons. And so that is because we are at middle to higher latitudes. Places that are around the equator, they don't have as much seasonality. They're pretty constant with their precipitation and temperatures, but we get some of that seasonality because we're at a higher latitude. So now we're going to talk a little bit about microclimate. That again is just with very small communities, so like shade. If you put shade somewhere, that can change a micro community, or just changing the wind patterns a little bit. There's examples of forests. Forests provide shade to some of the communities below them, and it keeps some of the moisture in. And so that's just a way that microclimate has influenced things. And the last thing we're going to talk about briefly is long-term climate change. So scientists are really interested in how our climate is going to change in the future, because we know that temperature and precipitation especially, which are both aspects of climate, have a huge impact on the terrestrial organisms that can survive, so both the plants and the animals. And so as we change the climate, we're going to be drastically affecting our biosphere. And so scientists have been able to track climate changes over the past. They've been able to see that thousands of years ago, the Earth was covered with glaciers and how that impacted the wildlife. And now they're looking towards the future at our current climate changes and trying to predict how that's going to affect our life and the life around us. That is all for today. I hope that was helpful. I hope you understand climate better, and a little bit why we have different seasons, and the different variations that we can get, all because of Earth's tilt of the axis. Thank you so much for watching, and have a fantastic day.